Okay, after we identify the or find the X homogeneous here, now we will find the particle solution or the XP. The right hand side is equal cosine 70. Now we will assume base, as we said before, we will assume base on the right hand side. Assume XP sub t is equal a naught cosine. Here actually alpha is equal 0 polynomial degree. Here 0 polynomial degree. Alpha is equal 0 for the exponential, and just we have the beta which is equal 7. So we have عندنا دالة مثلثية. We will assume the XP based on that triangular function. The assumption here, a naught XP sub t is equal a naught cosine 70 plus b naught sine 70. As we said before, we need, after we assume the XP, we need, before go with the derivative for the first derivative or second derivative, we need to check, do comparison with the XH, then we can continue after remove if there is any similarity with the homogeneous solution. Now if we will do comparison with this one, there's similarity, so we will multiply by, t, small t. Now we will do again the comparison. Now there is no comparison between the assumed XP with the XH. Now we will continue to do the derivation. X bar, we know that X bar, then X double bar or double prime, then we will go to substitute X double prime here in this equation, into the given differential equation. I mean the one that already derived before. After we include the air resistance is equal 0, we already substitute A naught is equal 49. We will assume we will substitute the X double prime plus 49 multiplied by x, which is the assumed XP after we include the remove the similarity with with X homogeneous. After we substitute, as we said before, the equation, the right hand side, it will be cosine 70. We rearrange these parameters to get it. Actually, the idea here just to find A naught, B naught that we already assumed in the particle solution. Here the B naught is equal 1 divided by 14, A naught is equal 0. We will assume it in the assumed. We will substitute it in the assumed XP. So the particle solution 1 over 14 t sine 70. Okay, the important things or the wrong or the mistake that already get it to the students before, actually they find the C1 and C2 for the homogeneous solution before finding the particle solution. This is actually wrong. We need to finish the X general solution to find the X general solution. If we have the right hand side, if we have phi sub t, then assume it with the X homogeneous to get it the X general solution here. Now we can go to find the arbitrary constant C1, C2, and as we said before, the xp sub t we have the value for the constant. Okay, now we will benefit from the circumstances or the condition that we already given us in the equation. Normally at t is equal 0, at t is equal 0, x is equal x naught. Okay, let's see what they said in the and they said now we will solve actually this equation for number a. They said before, when the motion at t is equal initially at x is equal 0.10 centimeter, which is 0.1 meter. Now we will benefit from this initial condition. We'll substitute it in this equation. X is equal 0.1 c1 multiplied by cosine 0 plus 0 plus 0. So we get a c1, which is 0.1. We'll substitute the c1 here in the equation. We'll substitute c1 here. Okay, now we'll benefit from the another condition. They said the initial velocity is equal 0 with respect to the number a at t is equal 0. To substitute v naught or v is equal 0, we need to do the revision for this one. We did with the revision. Now we'll substitute at t is equal 0 to get c2 is equal 0. So the final general solution, for this part, 0.1 cosine 70 plus c2 is equal 0 plus 1 over 14t sine 70. We will do actually the same steps for part B. At t is equal 0, we have the distance 0.15, which is 150 centimeter. We'll get c1. We will substitute the c1 into this equation. To substitute at t the initial velocity, we need to derive the equation before. We derived this one. We get it the first order, the first derivative. Then we assume the velocity here, which is 105 centimeter per second. We move it to meter per second. Now we will get it the c2. We will substitute the c2 into the equation. Now we have the x general solution, which is the x particle solution here, x particle solution, and we have the x homogeneous. This is the particle solution. Thank you.